Chapter 7, Lesson 2 of Geometry, and we want to look at similar polygons. You remember earlier this year we looked at congruent polygons, and congruent polygons were polygons where all of the corresponding angles were congruent and then all of the corresponding sides were congruent. And then we used that definition particularly with triangles, and we proved triangles congruent by proving all their parts congruent first. And then we were able to prove them by just showing three parts were congruent using SSS, SAS, and those postulates and theorems. And then once we knew that the triangles were congruent, we could apply CPCTC, or corresponding parts of congruent triangles, to then write equations to find missing lengths. So we want to do the same thing with similar polygons. So we're going to need to identify polygons as being similar first. So how do we do that? And then once we can identify similar polygons, what equations or properties will we be able to use in order to make some calculations? So let's look at how we identify similar polygons first. Now, the definition of similar polygons or similar figures are figures with the same shape but not necessarily the same size. And then it gives two characteristics that similar polygons must have. Two polygons are similar if, number one, the corresponding angles are congruent. So number one, we have to know that the corresponding angles are congruent in order for these to be similar. But then it goes on and says, and means this also has to be true, that the corresponding sides are proportional. Now, proportion sounds like something we've done before in this previous lesson. We looked at proportions. And proportions, you remember, is a statement where two ratios are equal. So if the sides are proportional, what's going to happen is we're going to compare the sides in one figure to its corresponding side in the other figure and write a ratio. And then we're going to take another side and write a ratio and its corresponding side. And we're going to do that with as many sides as the polygons have, and we're going to write an extended proportion. We're going to put all of those ratios equal to each other. And then we're going to look and actually test, well, are they actually equal? So we'll reduce each of those ratios and see if we come up with the same one. If we come up with the same ratio for all of the pairs of sides, and we have all of the corresponding angles congruent, then we can identify those figures as being similar. Now, I want you to think about these two questions before I move on. Are all squares similar? And then, are all rectangles similar? And I want you to write your answer down right now, and then after we talk about it, see if you were right, or see if you were correct in your conjecture. So let's look at these two rectangles and determine, are they similar? Well, because this is a rectangle and this is a rectangle, we know by definition that they have right angles. So the corresponding angles, this angle and this angle, are the same measure. They're both 90. This angle and its corresponding are the same measure because they're 90. This angle and this angle, and then this angle and this angle. So we know that the corresponding angles are congruent. That meets condition number one. Condition number two is, if we write the ratio of the corresponding sides, will we get the same one? Now, before I write my ratio, I need to decide what is going to be in my numerator and what is going to be in my denominator. Now, this does not matter. The only thing is that once you've made your choice, then you must stick with it with all of your ratios. So let's write this with the smaller rectangle sides in the numerator and the larger rectangle in the denominator. Okay? So if we take a look at this smaller side here, that's a 5. So I can write that in my numerator. And then the larger rectangle, its corresponding side is 15. So if I write that as 15. And now if I reduce this fraction, I have 1/3. So the ratio of this side to this one is 1 to 3. Okay? Now let's do the same thing with the other sides. Okay, so this side is a 9, so I'm going to write, again, smaller rectangle in the numerator, because that's what I chose to do. And then this side is 27. 9 over 27, which reduces to 1/3. So the ratio of the sides are exactly the same. Therefore, these two figures meet the condition of having all of their corresponding angles congruent, and the sides have the same ratio or the same proportion. Therefore, these two rectangles are similar. Okay? Now, while we're here, I want to make an important note about what this ratio is called. This ratio, if it's the same for all of the sides, is called the similarity ratio. And this is very important. I'm going to talk a lot about similarity ratio moving forward, because it's the similarity ratio that's going to allow us to then make equations or set up proportions that will then allow us to calculate missing sides. And without the similarity ratio, it can't be done. So we're going to be determining what the similarity ratio is first, because that's what determines whether they're similar. And if they are similar, we can then write this similarity ratio. We can then write other ratios, setting them equal, and then use the property of proportions in order to solve for missing length. So just remember, very important, this ratio that you get, if it's the same for all the corresponding sides, is called the similarity ratio. So you want to make sure you remember that. All right, so for what we've said here, for them to be similar, the corresponding angles have to be the same, and the sides must be proportional. So again, we have two rectangles, so we know that the corresponding angles are congruent. So now we do the ratio of the sides. So I take the 7 over the 21, and I put the 15 over the 25. 7 over 21 reduces to 1/3. 15 over 25 reduces to 3/5. Those ratios are not the same. Therefore, these sides are not proportional. So these rectangles are not similar. So what does that did you answer that question correctly? All rectangles are not similar. Just because they're rectangles doesn't mean they're similar. So you have to look at the proportions of the sides, or the ratio of the sides, excuse me, in order to determine if they're similar or not. And they're only similar if the ratio of the sides is the same for every corresponding side. So let's do this one more example to see if we can't figure out, are these polygons similar? So as I look at these trapezoid, I have to look at the angles. R will line up with angle Z, and they are congruent by the tick marks. S and W are congruent, Q and Y are congruent, T and X are congruent. So all of the angles are congruent. So it's all going to come down to the ratio of the sides. Now again, we have to remember which trapezoid we're going to put in our numerator and which one we're going to put in our denominator, so that we write all the ratios the same way. I'm going to take this trapezoid that's on the top and put it in the numerator, and I'm going to take this trapezoid that's on the bottom and put it in my denominator, so I write all my ratios the same way. So I take this side 10, and its corresponding side is 7.5, and I reduce the fraction. So I need to move the decimal over 1. We talked about how to do that. So we move it over 1 in both, and then we reduce. Dividing by 25, I get 4/3. Then I need to take the side, 16, over this side, 12, dividing both by 4, and I get 4/3. And then I need to take this side, 8, over this side, 6, and reduce it 4/3. So I have the same ratio for all of the corresponding sides. Therefore, these figures are similar. Now, what is the similarity ratio? The similarity ratio is 4/3. And then moving forward, if I wanted to calculate something in regards to these two trapezoids, I would begin with this ratio, and we'll show you how that goes in the next video when we start applying these. Okay, so again, there's two characteristics. It's very important to understand. I'm going to go real fast in here. Two characteristics: the corresponding angles have to be congruent, the corresponding sides have to be proportional, and we already answered this question. No, all rectangles are not similar. We still haven't answered this question about all squares, but you think about that one. I'm not going to give you the answer for that one, and see if you can't figure that out.